welcome everyone to our fourth manure management and utilization technologies webinar. This is our first of two that are going to be focused on anaerobic digestion topics. Just as a little bit of background, my research here at Purdue, I'm a graduate student here at Purdue, and my research is in anaerobic digestion, and is part of my research and part of a grant we received from the USDA AgSTAR program. We wanted to share this research with other people and get more visibility for anaerobic digestion in general. So we've organized two webinars. The next one will be in November. We'll announce more information about that again at the end. But we're very excited for this. Our first speaker today is Nick Elger. He is the program manager for the EPA AgSTAR Program and serves as the co-chair of the Global Methane Initiative Biogas Subcommittee. In his role as program manager for AgSTAR, Nick works with the U.S. livestock industry, state and federal agencies, and biogas industry stakeholders to advance deployment of methane recovery projects. While supporting the Global Methane Initiative, Nick helps advance anaerobic digestion of organic feedstocks globally for methane mitigation and energy production. Nick graduated from the University of Minnesota, where he received his Bachelor of Science degree in Environmental Sciences, Policy and Management, and is currently a Master of Business candidate at the George Washington University. And with that, we'll turn it over to you, Nick.
Okay, great. Well, thanks for the introduction, Jenny, and thank you to Purdue University for putting on this webinar today. And I think it's a really great opportunity to share more information and best practices on anaerobic digesters and renewable natural gas. And the more information we can share on these systems, hopefully the more these systems can be a useful tool for farms to manage manure more sustainably. So today I want to give some basics and best practices about anaerobic digestion. So I'll share a little bit of an overview of the US EPA AgSTAR program, and then dive into the Anaerobic Digester Project Development Handbook and pull out some of the best practices from that handbook. And then we can wrap up with some questions and answer if people would like. So the AgSTAR program, it's a partnership program. It's non-regulatory, and it's collaborative between US EPA and the US Department of Agriculture. Both agencies help fund the program. And the whole mission of our program is to help promote sustainable manure management practices. And in particular, we've been focusing on anaerobic digestion and as the solution to help manage manure more sustainably and as an economic solution as well. We have really strong ties with government agencies at the federal level as well as the state level. We work a lot with non-governmental organizations, universities, and the private sector, of course, to help advance these systems and best practices on farms across the US. And we really provide a lot of tools and resources to help develop more of these systems across the country. Just to kind of take a 100,000-foot view of why US EPA, USDA are focused on this, on anaerobic digestion, and it largely comes down to a big focus on methane emissions. Manure management is a fairly large source of methane emissions in the US, accounting for just under 10% of the US's methane emissions. And of course, methane is a powerful greenhouse gas. So capturing and utilizing that methane beneficially in an anaerobic digester system is a win-win for both the environment as well as oftentimes beneficially economic for farmers. So digesters, there are a number of best practices for managing manure sustainably. Digesters are one of the tools in our toolbox to help manage manure sustainably. And this graphic here kind of describes the process of anaerobic digestion. So different feedstocks, whether it's manure or wastewater biosolids, food waste, or other agricultural residues and wastes, can be digested singularly or in combination in an anaerobic digester. And two products can come out of the digester: biogas and digestate. Biogas is beneficial. It can be used for energy production, whether it's electricity, heat, vehicle fuel. Renewable natural gas is a big end use for that biogas now. And some companies in the US are even creating bioplastics from it. On the other side, digestate is a nutrient-rich, beneficial fertilizer product that can also be used for animal bedding. In some instances, it's used to create other horticulture products. So a number of benefits from the anaerobic digestion process. And it really, at its basic core level, it's pretty simple process. All you need is organic feedstocks, heat, a bacteria consortium, and time, and then eliminating oxygen, and you have biogas that can be created. I've mentioned a few of these, but there are a number of benefits of anaerobic digester systems, from environmental, energy, and economic. Anaerobic digestion can reduce methane emissions, which again is a powerful greenhouse gas, but it's also a precursor for ground level ozone, which is a big air quality concern for many communities around the country and around the world. Anaerobic digesters can also reduce odors, which is another air quality issue for many rural communities. I grew up in Wisconsin and remember every spring and fall when the manure is applied to the field, it's a stinky thing. And digesters, a great benefit of them is it can reduce odors from that manure. So when it's applied to the field, there's less odors produced. Digesters, again, they can also improve water quality by reducing pathogens in the manure when it's applied to the field, and also managing nutrients more sustainably so that it can help reduce leaching into surface and groundwaters. Improving soil health when that digestate is applied to the field, it can help recycle nutrients in the soil and regrow crops with those nutrients. And there's been some studies shown that digestate actually helps increase crop yields. From the energy side, this is locally produced, a clean energy. It can help increase energy independence of communities and displace the use of fossil fuels. And from an economic standpoint, the two products, energy and digestate, can help diversify farm revenue from the sale of those products, as well as sometimes receiving tipping fees. If a farm digester is receiving food waste or other waste and managing it in a digester, these can create local jobs. And oftentimes there's partnerships that can be formed with local businesses to manage wastes in anaerobic digester systems. The AgSTAR program, we track projects across the country for a number of benefits. Understanding where these systems are so that we can share this information with farmers and stakeholders to learn from projects and what works well in their area of the country, what doesn't work. And actually a lot of the greenhouse gas data that we receive from these projects actually winds up in the US's national greenhouse gas inventory. So these projects help contribute to the US's goal of reducing our greenhouse gas emissions. And just quickly, actually, on this map, this is on our website, so you can take a look and learn more about where projects are and the types of projects that are across the country. So we have been tracking this data for a number of years, and digesters have been growing, especially over the last couple years here, largely driven by incentives from the Renewable Fuel Standard and California's Low Carbon Fuel Standard credit, which is really driving the growth in renewable natural gas projects. And so there's currently around a little over 300 anaerobic digester projects on farms in the country. But that growth is really ticking up very quickly, and it's expected to exceed 500 digesters, we project, in just the next 3 years. So That's a huge growth. But all that's to say is there is a huge potential for additional digesters. We worked with USDA to do and make market opportunities assessment of digesters in the US. And we estimate that there's potential for over 8,000 digesters on farms in the US. So we're just scratching the surface in the US, and there's great potential for more of these on farms. So these next couple slides, I just want to show a couple examples of applications of digesters on farms and some successful models that have worked. So this first one is in Deerfield, Massachusetts. This is Barway Farms. This is a Vanguard Energies system. And the unique thing about this farm is it's a third party owned and operated. Vanguard owns and operates the system. There's a relationship with the farmer to take in the manure and manage it in the digester, and the farmer gets some of the energy as well as some of the bedding, the digestate for bedding for their cows. But they also have relationships with some local food waste producers. So they're bringing in food waste from the community and mixing it with the manure to create energy. And one of the big challenges for getting more digesters in the country is scaling these systems down to smaller farms. This farm only has 250 cows, but they're able to have a 1 megawatt facility at their farm. So these digester systems can be scaled down to smaller farms if food wastes and other organic wastes are co-digested. And there are some other technologies that are being scaled down right now as well too, to reach those smaller farms. Another example is Freund Farm in Connecticut. This is again a small dairy farm, only 300 cows, but the farmer there that runs this system created an innovative product called cow pots, and these are available online and in many stores across the country. These are biodegradable planter pots made from cow manure. So again, creating value not only from the energy, but from the digestate and creating a saleable product. And then my last example today is on renewable natural gas to vehicle fuel and cluster farms. This is a big business model that's cropping up in California to start and beginning to expand across the West and really across the country as a way to take advantage of economies of scale. Again, as I mentioned, digesters are a little bit more costly on smaller farms and challenging to develop, but this model is, for example, the California Kern cluster is bringing together 15 or more, actually, I think it's expanded now, dairies, and taking all of the biogas and bringing it to one central location to be cleaned up and turned into renewable natural gas. And I know some of my other speakers are going to be talking more in depth on RNG, but this is a really model that it is able to bring in a number of farms to take advantage of economies of scale and build more digesters across the country. So these next couple of slides, the rest of my presentation is really going to dive into some of the best practices for developing and operating these systems. And it all is based on a resource that AgSTAR worked with our partners at USDA, as well as a number of experts across the country, Tetra Tech, Michigan State University, the list could go on. A number of experts contributed to this resource. But it's really the latest knowledge on best practices for digester systems. And the whole goal is to help provide a framework for developing anaerobic digester systems. And it can be useful for farmers, for project developers, financiers, policymakers to really understand these systems. There's 11 chapters in the handbook, going through everything from the basic process fundamentals, talking about feedstocks, energy, digestate, economic and financial factors, permitting, and safety and operations. So I'm going to go through a number of these chapters in the handbook over the next couple slides. And I just want to start out with if you're considering building an anaerobic digester, good planning from the start is very important to avoid disappointing results. And working with a reputable company can help avoid a number of pitfalls. One thing that can be a challenge with these systems is that they're very complex. The technology can be complex. This is a biological treatment option, so there's a living technology as well too. It's mechanical, so there's a number of things going on. And so working with a reputable company can help avoid, inappropriate design of technology. You can have if you have a good company, can help you run the system more effectively, making sure that it's optimally producing gas and digestate, and really operating at its full potential to avoid, systems shutting down and other consequences of inappropriate operations. And when developing these projects, starting with the key design concepts, looking at really to start with what are your project goals? If you're looking at building one of these systems, how will a digester integrate into your business? Take an understanding of what your financial goals are, what your long-term vision of your business are with the addition of an anaerobic digester system are really some key first things to consider. Importantly, after that, looking at feedstock, a digester it only functions if it has feedstock, and if that feedstock is, well understood and managed appropriately. So I'll kind of dive into that in the next couple slides. Again, these systems, need heating and mixing to maintain optimal biogas production. So understanding those, and then on the back end, having a plan for how you will use the biogas in the digestate. So there's a number of feedstocks, as I said, that can be used in a digester, from livestock manure, from whether it's cows or pigs, poultry manure, to food waste, organic residuals. A number of other organic feedstocks can be used, but it's very important to have a plan for understanding how much energy can be produced from these systems, and so that they can be managed effectively. On the left-hand side here, manures, as I said, these are great for producing microbial populations in a digester. They have lower energy potential, but they really can be help stabilize biogas production in the anaerobic digester. Other feedstocks, fats, oils, and greases, food waste and other things can really bring high energy production potential to these types of systems. So we saw that one example of Barway, how they only had 250 cows, but they're bringing in a lot of food waste. That food waste is really producing a lot of that energy. So it's really important to find the right mix and to work with a appropriate engineer to understand and run the calculations to optimize the system. For some reason the graphic's not advancing, but this is again just kind of showing the different productivity of gases in the system. The manure is at the bottom in the green and black, and the red is the food waste. So there's some modeling that can be done beforehand before just adding in food waste. So it's very important to do some of that estimations for biogas production so that it can be run most efficiently. So getting into digester types, there's a number of different digester technologies that are out there on the market. And really what is most important is each of these can work for different situations. Not one technology is best for all solutions. So, there's covered lagoons, which work really well in, warmer climates and climates where there's more liquid, higher moisture content in the manure going into the digester. There's complete mix systems, which a lot of times require heat to be, and those have benefits, commingling food waste as well into them. There's plug flow systems, fixed film systems. So each of these have their pros and cons, and the AgSTAR project development handbook goes into a lot of those details about which systems work best for which feedstocks and which climate, what type of farm you have. So biogas uses, I mentioned there's a number of different uses of the biogas: electricity production, heat and power. You can use the biogas directly. You can also flare it, which is important if you don't have a use for it, so that methane doesn't go directly into the atmosphere. And then renewable natural gas for vehicle fuel or other uses. And this graphic here just shows the use of biogas in the country tracked over time. Most of the country uses anaerobic digestion biogas on farms for combined heat and power and electricity. But at the bottom there, you can see there's an uptick in RNG and CNG for vehicle fuel. So that share of the energy use across the country is growing. Number of uses for the digestate. A lot of farms can use can separate the solids from the digestate and create animal bedding, which can replace sand or wood chips or other things, which can save farms money. You can use the digestate for adding nutrients to soil, and separating the solids and liquids is a good way to apply that liquid base to the field as a nutrient beneficial product. So getting into the economics and finances of these systems, one of the most important thing to consider with an anaerobic digester is the capital investment. And so assessing what is needed for capital investment is a really good first step. Having a business plan that can account for the capital investment, operating costs of a system, what the construction costs are, and taking into account what the owner's budget are is really critical steps. And over these next couple slides, I'll get into some of the other items to consider when considering economics, but I just want to show this kind of graphic that's used by our friends over some developers to kind of think about how to cost these systems. When you're first getting started, there's a large margin of error, but as you do more of your planning to concept stage, preliminary design and construction, you get more refined cost estimates of the ultimate project. So just something to consider when going through this process of building one of these systems. So in addition to the construction costs, there's the operating costs. Can't forget about that. These systems require daily labor, operations and maintenance of both the digester, the energy production system, removing H2S and other contaminants from the gases. Can't forget insurance and other management of these systems. So it's a lot of times we found that it's underestimated, the amount of cost for labor, which can really come back to bite owners and operators of these systems. So our handbook kind of dives into deeper some of the considerations on operations costs and maintenance and what is needed to appropriately estimate those prior to going into developing these systems. So project revenues, as I said, these systems can have great economic benefits as well too, from the sale of biogas and digestate. Right now, through the Inflation Reduction Act and other acts by state governments, there's a number of tax credits that are available for these types of systems. So now is a great time to develop these systems and take advantage of these market incentives that are available right now. In some markets, there's carbon offsets and renewable energy credits or RECs. As I mentioned, there's the renewable fuel standard and low carbon fuel standard credits, which are helping to provide a financial incentive for these systems. If you're producing co-products from the digestate, whether it's organic nutrient products or planter pods, that's another source of potential revenue. And of course, if you're bringing in food waste from outside, you can actually earn revenue from taking in that food waste through tipping fees. So back when these systems were first being built on farms in the US, a lot of times the onus for developing and operating and maintaining these systems were all on the farmer. Farmers are very busy. These systems really require a lot of attention to manage if they're going to be managed most efficiently and optimally. So really the successful business model is going towards third-party owned and operated systems. And there's a number of benefits to those that can, just take a lot of the risk off of the farmer and share the risk and the reward with both the farmer and a third-party company. There's a new business models coming out where, whether it's partners along the value chain are being brought into the project, whether it's energy cooperatives being part investors in these systems to and then receiving the energy, customers, whether it's food waste producers having an agreement to supply the food waste to the digester and then on the back end purchasing some of the energy. So there's a lot of different models that can bring in other organizations and partners that can help diversify the risks and rewards of these projects. Another thing about the handbook and the AgSTAR website is, we have some resources on financing of these systems, whether it's equity financing or debt and equity financing, and how grants and cost sharing and loan guarantees, bonds can be included in that financial modeling. So if you're along to the point of exploring the financial aspects of these types of systems, we have a lot of great information on our website. One other thing, I started to mention this on 2 slides back, but business relationships are really key to successful digesters. As more partners are being brought in, having those business relationships are critical to a successful projects. If you're creating the energy, you need to have a good relationship with the off-taker, whether that's the electricity or the gas producer, and talking through those agreements and early and often with those interconnection companies is really key step to having a successful project. There's also the organic feedstock contracts. If you're bringing in food waste, having good relationships with them, financiers, construction, operation, facilities. So just keeping in mind that there's a number of relationships, business relationships that are key to successful projects. Of course, with any infrastructure project, there is permitting that's required. Digesters are no exception to that. And these systems being on farms, and because they impact the environment as well too, there's a number of permitting requirements: air quality, water quality, land use. Many states require, if you're bringing in food waste, may require some permitting to bring in that food waste. Energy, a number of different requirements to consider before going into this. And the Anaerobic Digester Handbook talks at length about some of these different permitting requirements, what to look for, how to navigate the process in your state or in your community. So I encourage you to take a look at that chapter in the handbook. And then just kind of wrapping up, I started to mention this, but really having public and community outreach and engagement early and often is a key factor to success. These types of systems, they're energy production facilities, and there's going to be a lot of questions from neighbors about these types of systems, and getting ahead and conducting outreach, having, community engagement opportunities to share what's going on with this project, how it is a benefit for the community, what the impacts will be, is really important. Having that transparency. I think the lessons learned from projects that haven't had as much community engagement is there can be community skepticism and disinformation about what this project is doing. So as much as you can get ahead and be proactive and engaging with community leaders and neighboring businesses to build that trust, it will really benefit the project in the long run. So this slide kind of has a number of examples of some of the things to consider when working with the community. From, if you're going to develop this, you may need to go to the zoning board and have that conversation. So having those conversations is important. Communicating with the public about how the waste will be managed. Will you have a spill response plan, and a safety management plan, an odor management, and what that benefit will be for the community, and what will the benefit be for the community, and how will this improve things for the community. Sharing those is a really important best practice. So all these best practices that I talked to are available in the handbook, and that's on the EPA AgSTAR website. So I encourage you to access that, to dive deeper and to learn more about operating and maintaining these systems. And if you have any other questions, EPA AgSTAR is here to be a resource for anybody across the country that's interested in developing these systems. So please reach out to us through the EPA AgSTAR website, or contact me directly if you have any additional questions. So thank you so much. Great to be here and happy to answer any questions.
Thanks so much, Nick. That was very informative. We have several minutes for questions. We're hoping that this would be a pretty interactive event. If you have any questions, you're welcome to put them in the chat or come off mute as well. Looks like we've got a question in the chat. Does AgSTAR or EPA have guidance or rules for land application of digestate as a soil amendment or fertilizer?
Thanks. That's a great question. The handbook does get into land applying the digestate. There are some considerations depending on what the feedstock is for that digester. So yes, the handbook absolutely does. And if you have some specific questions, I'd be happy to work with you. USDA also has some resources on that, and would be happy to share more information on it.
Awesome. We have another question about sharing the presentation. Just to make sure everybody is aware, we will be sharing this recording online. And Nick has agreed that he would share his slides as well. We can send those out as well. We've got another question. Does AgSTAR provide guidance on management of liquid fertilizer?
Yeah, that's a good question. The handbook has some information on the liquid digestate and land application of it. A lot of the requirements for land applying fertilizers are need to be considered in nutrient management plans, and that's discussed at length in the handbook, kind of some of those considerations. But if you have some specific questions, Amit, I'd be happy to follow up with you. Please reach out if with whatever your question is. And if we don't have the resource available on the AgSTAR website or more information, I'd be happy to follow up with you.
Got another question here. Can you explain CNG versus RNG?
Yeah, that's a great question. And it's there's really not a big difference. CNG is compressed, we think about compressed natural gas. So that is when it's largely being used for vehicle fuel. That's just kind of how we've been tracking it in the database. RNG is renewable natural gas, which could be compressed into vehicle fuel or used for other purposes downstream. So not a big difference, kind of a minor kind of difference in that. And one thing I'll note is we want to try to make that distinction more clear in our data. So we're right now undergoing an update to our anaerobic digester database, so we can more clearly define some of those end uses, whether it's for vehicle fuel or other purposes.
Awesome. Another question, is there a loss of bacterial culture that degrades organic matter during the anaerobic digestion process?
Not sure I fully understand the question, but digesters have a bacterial consortium in the system. There's always there's always a turnover of bacteria in the system. They don't live forever, so maintaining that healthy population is really important to the digestion process. So yeah, I mean, I think a healthy bacterium will make sure that healthy bacterial population will make sure that these systems are operating most efficiently. Sorry if I didn't understand your question correctly, but I think that's the best I can share right now.
Yeah, if anyone, if you need to follow up on that question, feel free to put more in the chat. We've got a few more questions here. Does AgSTAR work directly with lenders for loan guarantees?
We haven't worked directly with lenders, but we'd be happy to have a conversation about how we can potentially be of help to you. The USDA, we work really closely with USDA, and in particular their Rural Energy for America program and their Rural Development Program, which provides loan guarantees and grants through their REAP and EQIP programs. So be happy if you're interested in having a conversation with them. I can also connect you with them as well too. AgSTAR does not have any grants or loans that we offer through EPA, but again, USDA is the agency that offers those.
Okay, are there nutrients reduced in manure after digestion?
I'm not an expert in this topic. I think that the nutrients are managed in an anaerobic digester. I'm sure that there are some very, very minor nutrient loss due just when the bacteria digest the substrate in the digestion process. But for the most part, the nutrients are stabilized in a digester and allow farmers to manage them more efficiently. And maybe Jenny, if you are or others on the line, feel free to jump in too.
I know we've got a number of different experts here, so any of you are free to chime in the chat as well. But from my understanding, what Nick said is correct. Okay, let's see. Here's another question: is there any data available on nutrient recovery technologies for the digestate? Areas with dense livestock production often show a need to move nutrients further and further away from the farms.
Thanks, Teresa. That's a really good question. And AgSTAR, we're a voluntary program that collects data from voluntary sources. We don't require farms to report data on their systems or nutrient technologies. So right now that is a lack of data that at least AgSTAR has. We're not sure of all of the available technologies and how they're used on farms across the country, but that's a great suggestion and something that potentially we can work with partners and at USDA or others to have more information about how nutrient recovery technologies are used. We have some information in the handbook on the different technologies that are commercially available right now, but as far as their use on farms across the country, I'm not sure.
Awesome. Gonna jump to this question. What are your thoughts on the long-term ability to earn carbon credits? There's a concern that carbon credits may decrease in economic viability as electricity did in the past.
Carrie, really good question. I'd be speculating just like you about the long-term ability of the carbon credit markets. You know, I know it's fluctuated over time. Some countries, you know, especially Europe, is looking at a global carbon credit market. There are some markets that are out there right now. I'm not sure on that, and I wouldn't be the best person to ask.
We do actually, not in this webinar, but the next webinar that we'll be holding in November, carbon credits is actually one of our topics. We'll have a speaker come in and talk about all of those different aspects. So I encourage you to register for that one. Got a few more questions here. Do you know if digesters will receive more addition and potential funding under the upcoming Farm Bill?
I don't know. I know that there's some conversations about that happening right now. I hope that there is additional incentives available for these systems. I know it's a priority right now for this Congress, and I hope that that can happen. But I'm not sure if that's going to be, you know, EPA is a little isn't involved directly in a lot of those conversations. It's Congress.
Awesome. Got another question about organics. Do you use the term organic to refer to the post-digest dates? Are they certified organic?
Thanks. Really good question. And when I use the term organic, I mean just biological products, so like living organisms, not organic in the term in the way it used as like certified organic or you know, that whole process. So that's what I meant by that.